Hello learners, this is Education Online program. I'm teacher Rose Hezekiah and I'm going to present for you a lesson in chemistry for senior 1 and 2. And our topic for today, we will look at coordinate or dative bond. We look at compounds, molecules and mixtures. So we will first start by coordinate or dative bond. So what is coordinate or dative bond? Coordinate or dative bond, or sometimes it is called coordinate covalent bond. So it is similar to covalent bond in a way that it also involves sharing of electrons. But the difference is that the electrons shared will be donated by only one atom. But in covalent bond, we have both atoms donate, and then the electrons donated will be shared equally between the two atoms. But in dative covalent bond, one atom will donate and the other one will accept. So, by definition, coordinate covalent bond is similar to covalent bond, except that they shared electrons are provided by only one atom. The atom that contributes both electrons, the atoms that contribute both electrons has a lone pair, will have a lone pair of electrons and behave as an electron donor. So we have similar to covalent bond, except that the shared electrons are provided by only one atom, and the atom that contributes both electrons will have a lone pair of electron and behave as an electron donor. So let us see an example. We have ammonia, that is NH3, is made up of one atom of nitrogen and 3 atoms of hydrogen. We say that nitrogen atom with atomic number 5, the electronic configuration is 2, 3. And then we have hydrogen, atomic number 1, electronic configuration is 1. But in ammonia, we have 3 atoms of hydrogen. So, we put it in another in a form of this structure. We have this one is the nitrogen atom. Then we have in ammonia we have 3 hydrogen atoms. We put one this side, and then the other one, and then the third one. So these are hydrogen atoms. And then we know that hydrogen has got only 1 electron in its outermost shell, while nitrogen has got 3 electrons in its outermost shell. So nitrogen will contribute all its 3 electrons, and hydrogen will contribute its only 1 electron. Then nitrogen, sorry, the atomic number of nitrogen is 7, is 2, 5. The electronic configuration is 2, 5, not 2, 3. So the atomic number is 7 and the electronic configuration is 2, 5. That is, the electrons in the outermost energy level is 5. So nitrogen will contribute 3 electrons to be shared by the 3 hydrogen atoms, and then nitrogen will have a lone pair of 2 electrons. Then a hydrogen proton that has got completely no electron. A hydrogen proton is an atom that has lost its only 1 electron. So the hydrogen proton will come and combine with the ammonia to give us ammonium ion with this structure. We have nitrogen, we have the 3 atoms of hydrogen, these are the shared electrons between hydrogen and nitrogen. Then this hydrogen proton will use these 2 electrons that is donated by nitrogen. That is here. There is this hydrogen proton will not contribute an electron for sharing. The electrons will all be donated by nitrogen, and hydrogen will have 2 electrons in its outermost shell. So this structure again can be represented in this form. So we have this. This is the bond, the single covalent bond between nitrogen and hydrogen, each one contributing 1 electron. So here, single covalent bond between hydrogen and nitrogen, nitrogen contributing 1 electron and hydrogen contributing 1 electron. Here also, this hydrogen atom will contribute 1, nitrogen 1. And then the lone pair of electrons of nitrogen, because we said the electronic configuration of nitrogen is 2, 5. So the 3 electrons will be here shared by these 3 hydrogen atoms, and then the lone pair of electrons will be donated to the hydrogen proton that is coming without without electron. Then we will have, instead of ammonia, we will have ammonium ion, and the dative covalent bond is represented with an arrow. So this arrow is indicating that nitrogen is the one donating the entire electrons to hydrogen. Then we have the rest of the normal covalent bonds, the sharing between hydrogen and nitrogen. So this lone pair will be donated to the hydrogen proton, and we have, this is the dative covalent bond. So in this, nitrogen will behave as a donor and hydrogen will be an acceptor. Nitrogen will donate the 2 electrons, behaving as a donor, and hydrogen will be an acceptor. So this is how coordinate or dative covalent bond is formed. So we said elements lose or gain or share electrons in order to gain stability. And then in losing or gaining or sharing, they form compounds. So we have what is called compounds. And compounds, by definition, a compound is a substance that consists of 2 or more elements chemically combined. 2 or more elements chemically combined together. Is a compounds, or we said a compound. A compound is a substance that consists of 2 or more elements chemically combined together. So we said elements either combine through ionic bonding or covalent bonding. And when we say chemically combined, means for a compound to be formed, a chemical reaction must take place. So, for example, we have compounds like sodium chloride, magnesium chloride. We have water that we use every day. So all these are compounds. Here we have 1 atom of sodium and 1 atom of chlorine. That is, we say 2 or more elements chemically combined together. We have 1 atom of magnesium and 2 atoms of chlorine combining to give us magnesium chloride. And then we say these compounds are either formed through ionic or covalent bonding. So we have sodium chloride is an ionic compound, magnesium chloride is an ionic compound, but water is a covalent compound. The structure of water in another way can be represented like this. We have one atom of oxygen and then the two hydrogen atoms. Sorry. We have the two hydrogen atoms. We have oxygen, we have hydrogen. And then each atom of hydrogen will contribute its only one electron, and oxygen will contribute one at each side. Oxygen atomic number 6, electronic configuration 2, atomic number 8, sorry, electronic configuration 2, 6. So when it contributes its 2 electrons here, out of the 6 electrons in the outermost shell, it will be left with 2 lone pairs. 2 lone pairs of electrons. So this is the structure of water. Sometimes it is drawn like this. And then we have the lone pair of electrons. So this is also a compound. So we said a compound is a substance that consists of 2 or more elements chemically combined together. So sodium chloride is the common table salt that we use. Then we have what is called molecule or molecules. We have molecules. A molecule is a particle made up of 2 or more atoms. It's a particle that is made up of 2 or more atoms that are chemically bonded together. For example, we have chlorine molecule. Chlorine molecule. The chemical formula of chlorine molecule is like that. So we have 2 atoms of chlorine, and the structure can be represented like this. That is we have 2 atoms of chlorine chemically bonded together. So they are bonded through covalent bond. Each one will contribute 1 electron. 1, 2. Because we said chlorine atom has got 17 electrons, or the atomic number of chlorine is 17. The electronic configuration is 2, 8, 7. That is 7 electrons in the outermost shell. Chlorine needs only 1 electron to have 8 electrons in the outermost shell in order to gain stability. So the 2 chlorine atoms will exist together through forming covalent bond by each one of them contributing 1 electron, so that we have chlorine molecule. So chemically bonded together. This is the bond. That is the covalent bond. And this covalent bond is formed as a result of sharing of this 1 pair of electron that is donated by both chlorine atoms. we have hydrogen molecule. Hydrogen molecule. We know that hydrogen has got only one electron. So we have hydrogen will only need one electron to have two electrons in the outermost shell, that is attaining the noble gas configuration that is similar to the electronic configuration of helium. So we have the two atoms of hydrogen. Each will contribute its only one electron. And then we have a single bond that will hold the two atoms together to give us the hydrogen molecule. So atoms are compounds composed of two or more elements chemically combined together. But a molecule is made up of two or more atoms that are chemically bonded together. Then we have what is called a mixture. What is called a mixture. Or we call them mixtures. And then a mixture, by definition, is a substance. A mixture, by definition, is a substance. Is a substance composed of elements, compounds, composed of elements or compounds. Elements or compounds not chemically combined together. So in a mixture, we can have compounds, we can have elements, they are combined together but not through chemical reaction. So example of mixtures can be ink or paints that we use for our paintings. So it can combine both elements or compounds, but they are not chemically combined together. That is, when we form mixtures, no chemical reaction usually takes place. So we have a table here that is illustrating the differences between a mixture and a compound, or mixtures and compounds. So we have the first column, we have a mixture, and then we have in the second column we have compound. So the substances in it can be separated by physical means, for example filtration. That is, the substances in a mixture can be easily separated by through filtration, or can be separated physically, even by sorting. In a compound, the elements in it can be separated by chemical means only. That is, you cannot separate compounds, elements in compounds physically. You separate them through chemical means. For example, if we have have a solution, if we have a solvent that contains, like we have sodium chloride, that is a compound that is dissolved in water. For us to separate this solution, we boil. The water will evaporate, and then the solid sodium chloride will be left behind. Secondly, its properties such as color is average of those substances. That is when we form a mixture, all the colors or all what is within the mixture will be the really components that are there in the beginning. But in compounds, its properties are quite different from those of the elements in it. Like for example, when we start by sodium, we add sodium plus chlorine. What we get is sodium chloride. That is, in the beginning, we start with two different elements. We start with sodium metal and chlorine, and then we mix them to give us a new substance, that is the compound sodium chloride. Like if you have A plus B, you get C. That is, A is completely different and B is different. So A and B combine to give us a new substance, that is C. So we have sodium and chlorine combining to give us a new compound that is called sodium chloride. So we have the properties are different from those of elements in it. So we have the properties of sodium chloride will be different from the properties of sodium atom and chlorine atom. Then thirdly, energy such as heat is not given out or absorbed when a mixture is formed. So there will be no energy released or absorbed. That is, no chemical reaction will take place when we make a mixture. But in a compound, energy is released or absorbed. So we say that two or more substances chemically combine together. Chemical reaction always takes place when a compound is formed. And in chemical reaction, either heat is absorbed or released. Its composition is variable. That is, the amount of the components that gives us a mixture is different. For example, if we have a mixture that is made up of liquid and solid materials, we will not have the same amount of liquid mixed with the same amount of solid. Could be different amounts. But in compounds, the composition is not variable. Like we have one atom of sodium combining with one atom of chlorine to give us sodium chloride. So, these are simple differences between what we call compounds, molecules, and mixtures. So, generally, for any student learning chemistry, you must be able to differentiate between what is a compound, what is a molecule, and then a mixture. As I said, a compound composed of two or more elements chemically combined together. A molecule is made up of two or more atoms that is bonded together, and a mixture composed of substances can be a compound or element, but they are not chemically combine together. So we have come to the end of our lesson for today. See you in the next lesson. Bye bye.